Okay, so first part was just fill in the formula on top of the chart. All right, I think everybody got that. Rate times time equals distance. Tried to help you out a little. I told you the front row would be the Corvette and the bottom row would be the Yugo. All right, the way I taught you, fill in the variable column first. How fast? That's a rate. Rate of the Corvette, rate of the Yugo. Now you got 4 blocks to deal with. All right, if they leave at the same time, they meet in 4 hours. What's the time? 4 hours. All right, same time, meet in 4 hours. How do you get the distance? Multiply the rate times the time. Multiply the rate times the time. That's the first 2 questions. Chart's complete. Now you got to write the distance equation. Distance equation will come from the distance column. You have to decide, is this a total or a comparison? I tried to help you. I gave you that right there to help you think. 2 cars are 576 miles apart. If you can't think of what to do, draw a picture. Car 1, car 2. They're apart. The question says they meet. This is 576 miles, right? That's how far they are apart. So is that a total or is that a comparison? Does it say the first car went 576 miles more than the second? No. Does it say the second car went 576 miles less than the first? No. It's a total. Total comparison, the template is the first plus the second equals the total. 4x is a distance. Look at your chart. 4y is a distance. Look at your chart. 576 is a distance. The distance equation must have all distances in it. And that's a key concept, and we'll get to that again later on down the road. Any questions on 1 through 3? Anybody? Any questions on 1 through 3? Going to be doing similar things tomorrow on that quiz. All right, 4 and 5. So again, I tried to help you a little. I said, let's make the top row southbound. Let's make the bottom row northbound. Those of you that are smart filled in the formula up top. Those of you that are smart did that. Not everybody did. That wasn't a wise choice. Again, I'm going to fill in my variable column first. I look to the question, how fast? That's a rate. Therefore, my rates are X and Y. Now, I tried to help you out by giving you that 5 in that bottom northbound column. I tried to help you out. Okay. One goes south. That's the first one, right? And 4 hours later, the other heads north. Right? Now skip down. Look at the last part of the second row. After the first train travels, what's the time of the first train, the southbound train? 9 hours. Now, I helped you out. The second one left 4 hours later. It didn't travel 9 hours. It traveled 9 minus 4 or 5 hours. Again, I tried to help you out. How do you get the distance? Multiply the rate times the time. Multiply the rate times the time. Now for number 5, I asked you for the rate equation. It'll come from the rate column. And I have to determine, are the rates a total or a comparison? So I look up and I try to find something that involves a speed, right, a rate. And I find this. The northbound train travels 12 miles per hour slower. That is a comparison. Okay, what's the template for a comparison? First equals second, right? What is my first? Southbound. What is my second? Northbound. What is my rate of the first? Look at my chart. The rate is an x. What is the rate of the now northbound? Look at my chart. Rate is a y. Those are both rates. Now remember, they're not equal. We have to make them equal. And remember, it said the southbound train was 12 miles an hour slower. This is slower. This is faster. Slower and faster. A bunch of you guys have this wrong, and I didn't mark it wrong. Maybe some of you have it right, and I marked it wrong. Okay, the faster one is going faster. The slower one is going slower. You either need to take away 12 from the northbound. I'm sorry, I read it wrong. You need to add 12 to northbound. I'm backwards. I hate to get confused and confuse you guys because you're confused already. Let me go back a second. Let's go back and fix it. All right. Use my red. The northbound train travels 12 miles an hour slower. This is the northbound. This is slower. All right. Everybody with me? You were drinking the Kool-Aid a minute ago, and that's not good to drink the Kool-Aid. You need to question and raise your hands if I do something that doesn't seem right to you. Don't sit there. Raise your hand and say, All right, so the slower one is a smaller number. So what do you do with the 12? You got to add 12 to the slower one. Or you could have, and I think one or two of you did, take 12 away from the faster one, right? So it's either x minus 12 equals y, or x equals y plus 12. Any questions on 4 and 5? Any questions on 4 and 5? Now, again, on some of your papers, I said something like this. That's not a rate. Right? Or I said those are distances, meaning they have no business in a rate equation. The rate equation has all rates. So again, x is a rate. Y is a rate. 12 miles per hour is a rate. And therefore, everything in my rate equation are rates. You follow? Again, some of you, it says on your paper, these are distances. You can't use distances in a rate equation. Any other questions on those two? All right, 6 through 8. So again, first thing you got to think is, I'm doing a wind problem. Now again, I tried to help you. I already said x was the plane speed. You should have said y is the wind speed. X is the plane speed, y is the wind speed. You should have put your formula up top. Rate times time equals distance. You should have labeled your rows. The way we've always done it is with the wind or current is the top and against is the bottom. That's the way we've done it. And as I told you in this type of problem, with the wind is a positive, or current, and against the wind is a negative. And that's automatic on this type of problem. Okay, so let's finish up our chart. Let's see if we can get some times and distances. 727 leaves Dulles, and with the tailwind, the plane makes it the 937 miles in 1.5 hours. Time, 1.5 hours. Distance, 937 miles. Another leaves Miami heading to New York City and takes 2.25 hours to travel 1,158 miles. Tailwind is with the wind. The other would be against the wind. Okay, and then the two equations you could have done, and again, we like to reverse, right, the time to put it out in front, distribute. 1.5 times x plus y equals 937, and 2.25 times x minus y equals 1158. Look, if I only ask you for one equation, don't give me two. Because if you give me two and one of them is wrong, I got to take points off. So if I only ask for one equation, only give me one equation. Otherwise, if you get one of them wrong, I'm going to have to take points off. Now, it's possible to get number 8 correct, but not actually have the correct equation. In other words, you could have correctly read the equation from wrong data in your chart. If that were the case, I didn't take points off again from you. You follow? So if you used the wrong data in your chart, but used it correctly to write the equation, I gave you the credit for that. Any questions on 6 through 8? So remember, you got to keep straight when you're doing a wind current problem versus any other rate problem, right? You can't get those confused. If you do, that's going to cause you to miss those problems. No questions on the front? Everything's clear now? Okay, let's go to 9 through the bonus. Again, all I did was give you the skeleton of the chart on this one. Hopefully you put the formula up top. Rate times time equals distance. Now we got to figure out what we're going to label these things with. 2 buses leave Woodbridge. 1 p.m. the first goes north, so I put north. The second goes south, I put south. You didn't have to do it that way. All right, we got the formula up top. We got our chart. We've got the rows labeled. We're ready to do the variable column first. What are we asking for? How fast? So again, a rate, x and y. We got 4 blocks left. At 1 p.m., the first one leaves and goes north. 3 p.m., the other bus heads south. Finish reading. The southbound bus travels 8 miles an hour faster than the northbound bus. After the northbound bus travels 8 hours. Time of the northbound bus, 8 hours. Now to get the southbound, first bus left at 1 p.m., the second bus left 2 hours later. 6 hours. Right? First one traveled 8. Second one left 2 hours later. It traveled 2 hours less. It traveled 6 hours. I don't know how many of you put 1 p.m. and 3 p.m. in that block. You got to think, how in the world does the time of day, how would that compute to any answer? And it can't. So again, I tried to help you so you don't miss that again. I put time is always in hours. 1 p.m. is not in hours, and 3 p.m. is not in hours. I did try to help you here because this is a similar concept to this problem. And I helped you out by giving you the 5 in that one. So I did try to help you, but again, some of you missed that. So now we know that the distance is 8x and the distance is 6y. Okay, it's the way we do our problems. There are other ways to approach them. That is a way that is most simplistic. All right, I asked you for a rate equation. Rate equation is going to come from the rate column. So I have to decide, is this, and I didn't give it to you this time, is it a total or a comparison? Is it a total or a comparison? I got to look at the problem. Southbound bus travels 8 miles per hour faster. Faster is a comparison. First equals the second. What is the first? Labeling my chart tells me the first is the north bus. The second is the south bus. I know that because I labeled my chart. Again, the south is faster. Faster. So again, how do I get the rate for the north? I read it off my chart. X is a rate for the north. Y is a rate for the south. 8 miles per hour is a rate. If it's faster, I got to take 8 away from the faster one, or I could add 8 to the slower one. So some of you had x plus 8 equals y. That's fine. You're good. You could add 8 to the left or take away 8 from the right. How many of you labeled faster or slower underneath one of them? Yeah, a couple of you took that big tip that I gave you, and the rest of you didn't. And you're just making life harder on you. Okay? Because hopefully we should be able to compute, if it's going faster, I got to take it away to get them equal. Or if the other one's going slower, I got to add to the slower to make them equal, right? You're making them equal with that difference. Okay, any questions on those two? So again, I would say to you, for some of you, I said right in here, you're using things that are not rates. 8x is a distance. 8x is not a rate. Agreed? 6y from your chart is a distance. 6y is not a rate. 1,000 miles is a distance. 1,000 miles is not a rate. 8 hours is a time. 8 hours is not a rate. 1 p.m. is a time and 3 p.m. is a time. Neither of those are rates. Your rate equation has to have all rates. If you were doing a distance equation, it would have to have all distances. All right? Got that? Again, every time you do them a little bit more, hopefully you'll get better and better at it. Okay, find the speed of the northbound bus. So I do now need the other equation, the distance equation. Again, I have to decide, is this a total or a comparison? I look at the problem, 1,000 miles apart, that's a total. Therefore, I have 8x plus 6y equals the total distance, 1,000 miles. I'm going to solve by substitution because my rate problem is already solved for x. So where the x is, I'm going to sub in y minus 8. Go a little higher here. I'm going to distribute 8y minus 64 plus 6y equals 1,000. I'm going to add a positive 64 to both sides. I'm going to add my like terms and get 14y. And I'm going to divide the other side by 14, right? I'm going to take my calculator out and do 1,064 divided by 14, and I get 76. Anybody happen to put 76 in the blank? Because 76 is not the answer. Again, I labeled the rows of my chart, and I know that 76 is the southbound train. The question asked for the northbound. Therefore, I got to solve for the other variable. The northbound equals the y minus 8. Sub in the 76. 76 minus 8 leaves me a 68 miles per hour, which is the northbound. Okay. And you just got to follow through and take it to the end. Any questions on any of that? Okay, so tomorrow's quiz. Very similar. However, what other kind of problems do we know how to do now? Mixture. So you have to keep straight. Stop packing up. Everybody look at me. Leave your stuff alone and look at me. So tomorrow you got to be able to do regular rate, distance, time problems. You got to do wind current rate, distance, time problems. And then you have to be able to handle mixture problems. Those are the 3 things that will involve the quiz tomorrow. Will some of the questions be like this quiz? Yes. But I have a full period tomorrow because there's no homework tonight except for you studying for your quiz. And that means I don't have to go over homework in the beginning of class. You'll take your quiz right away. So you'll answer a few of the problems tomorrow, more than just a bonus, and take it all the way through to the end. But some of the questions will be filling in the chart. Some of the questions will be give me the blank equation. Okay? Any questions about tomorrow's quiz? One last note then. We have one more topic that's Thursday, and that's solving systems of inequalities. We'll finish that Thursday. We'll do homework over it Thursday and a Friday. Friday, I'll go over that homework and review one last time. And on Monday, you're having a test over this. I've gone as slow as I can. You had 2 week plus of snow days to deal with the first topic of time and distance. You should have had him down by then. So I've gone as slow as I can. Come Monday is Judgment Day. You better get ready for it. All right. You can now pack up.